Welcome everyone to our Exploring, Mapping, and Sensing Our Ocean section of Geography 2050. My name is Chris Verlinden and I'm the CTO of a little company called Applied Ocean Sciences. And before that, I was a Coast Guard officer. Today we're going to be talking about ocean exploration with some of the world's greatest explorers, and I couldn't be more excited to be here. I'd like to take a minute before we get started with our explorers to discuss why this is such an interesting and exciting topic to me. This picture right here is one that you might be familiar with. This is the world, as many of you are used to seeing it. The world as I'm used to seeing it looks more like this. This is just from a little bit of a different angle, centered on the Pacific Ocean. And you can see that we live on a big blue marble. The world is over 70% covered by ocean. And exploring that ocean is a challenge. What makes it difficult to explore is that human beings don't breathe so well underwater, and the crushing pressure at depths can make enormous engineering challenges for exploring and sensing the ocean. Beyond that, the ocean is four-dimensional. We have a volumetric body of water that has properties at every X, Y, and Z coordinate, and those properties change over time. So even if you sense someplace one time, it will change in the future. Additionally, we typically interact with our world through RF or electromagnetic radiation, either through optics with our eyes or sensors like LiDAR, radar, things of that nature, infrared sensors, multispectral. And most of these bands that we use for sensing in air and throughout most of the world don't penetrate very well underwater, which also makes the remote sensing of ocean depths very, very challenging. And what's more, it's expensive. To get heavy marine equipment to the ocean depths take tens of thousands of dollars per day in ship costs and related expenditures. So the ocean is big, it's volumetric, it's changing, it's opaque to our eyes and our sensors, and it's very, very difficult from an engineering perspective and expensive to explore. So that is why panelists like the explorers we'll be talking to today have devoted their lives to solving many of these problems and exploring the ocean depths despite all of these challenges. So I'd like to take a minute to introduce our panelists today. In no particular order, Dr. Don Walsh is a Naval Academy graduate from 1954 and retired at the rank of captain. He has a PhD in physical oceanography from Texas A&M and more awards than I could possibly name today. He was named one of the world's great explorers by Life magazine. He's dove on the Titanic and the Bismarck, and he currently holds a professor position in the College of Earth, Ocean and Atmospheric Sciences at Oregon State. Our next explorer is Dr. Kathryn Sullivan. She is the first American woman to have walked in space and to have dove to the bottom of the Marianas Trench, and the only person to my knowledge who's done both. In addition to her many achievements in ocean exploration, she served as an administrator for NOAA and an undersecretary of Commerce for Oceans and Atmosphere, and is currently a senior fellow at the Potomac Institute. Next is Dr. Bob Ballard. He is the president of the Ocean Exploration Trust, the director of the Center of Ocean Exploration at the Graduate School of Oceanography at URI. He is well known for the discovery of the RMS Titanic, as well as dozens of other notable wrecks and other marine archaeological discoveries. He was the first to film deep sea vents, and in addition to these notable scientific and exploration achievements, has done incredible work in scientific communication and popularizing the sometimes otherwise opaque world of ocean exploration to future generations of ocean explorers. Finally, Dr. Sylvia Earle is the president and chairman of Mission Blue, National Geographic explorer in resident, founder of Deep Ocean Exploration and Research, Inc., and with Mission Blue has created over 50 hope spots worldwide to protect delicate ocean ecosystems all over the world. I am absolutely honored to be speaking with all of you today. And it's an absolute privilege to chair this session. Thank you so much for your time. The format for today's session is open-ended. I'll start with a couple of questions and we'll see where the conversation takes us. I'd like to start with the question that I introduced briefly in the introduction, and that is that with 70% of our ocean surface covered by water, It has been said by some that by some measures, only 5% of the ocean has been explored. And a common quote that you hear in pop culture is that we know more about the surface of the moon than the seafloor. My first question is that true? And if so, to what extent is it true? And I'm going to go in the order I see on my screen there. So maybe we can start with Dr. Sullivan.
Sure. Thank you, Chris. It's great to be with you. I think there's a huge degree of truth in that metric. One can quibble on several dimensions, but let me just highlight one. Certainly from a topographic or bathymetric point of view, because of the factor that you cited, the opacity of the ocean to the wavelengths that we usually use for precision mapping, LiDAR in particular, we certainly do have, I think the number I know is about 400 times better resolution on the surface topography, not only of the moon, but of Mars, than we have on the bathymetry of the deep ocean seafloor.
Wow. Dr. Earle, you're next in the order on my screen. What are your thoughts?
Well, I'm still trying to get my mind around the combination of Dirk Pitt and Bob Ballard. That you had a dream of being some combination thereof. But back to your question, what makes the ocean, what makes Earth really special in the universe, as far as we know, is life. And most of it is in the ocean. And I really suspect there is life of some sort elsewhere, but nothing like what we have here. And it's the ocean where life surely originated on Earth. And it's where the greatest diversity and abundance of life really is. And we have literally just scratched the surface, just beginning to wrap our minds around not just the diversity and abundance, but we're beginning to recognize that all of the ocean is alive, that Earth is a biogeochemical miracle, and you can't pull them apart. I mean, you can look at the geology, you can look at the chemistry, you can look at the life, but you can't really understand any of those things unless you look at it as a integrated system. And is it more complicated? Yes. Do we know less about it than the moon or Mars or other parts of the cosmos? I think that's probably fair to say. At least we're beginning to understand the magnitude of what we don't know. And that's a great place to start.
Your point is very interesting. And, we talked about just mapping the seafloor and what percentage of that we've done, but the ocean's more than a seafloor. It's, the right. Physical oceanography, the chemistry, and the biology. And it's amazing to me that we're still discovering, new species, and not in, the small, phytoplankton only, but macrofauna, that we're still discovering every year.
I think even more exciting is the micro, the discussions that rage on about, are viruses alive, or are they just somewhere between the bio and the physical and the chemical? I mean, and that the ocean is where the action is with respect to viruses. And thank goodness they're there. If they didn't exist, we wouldn't exist. They're really
Absolutely.
Critical to the chemistry of the planet. And we're just beginning to lift the lid on the big questions about what viruses are. And occasionally one of them likes to choose us as a host and gets our attention, but the great majority are out there, down there, doing their wondrous things in terms of shaping the way the world works. And maybe it's a separate kingdom. We're the ones who like to put labels and numbers and categories of things. Viruses don't care. They're just whatever it is they are on all the rest of the microbial world. I mean, Ballard, you were there. The discovery of the archaea, for heaven's sakes. When I was a kid, that whole kingdom of life was not known to exist. Now we know it exists even in our own bodies. Huh. So
that's an excellent transition, Dr. Earle. So I was looking at some of the Nautilus live footage last night online, and I saw several times in which, species that had not yet been identified showed up there for the first time for the general public to see. And that got me excited, and I bet everybody else who watched it as well. And Dr. Earle also mentioned, some of the new species, and many of those species are in the hydrothermal vents that I also saw footage that you collected, Dr. Ballard. What are your thoughts on that? The statistic of only 5% being explored, and how much we know about the ocean versus how much we should know?
Well, I'm an earth scientist, and I've been looking at the planet as a total system, dominantly covered by water. But I've done 157 expeditions at sea and probably zillions on land. I don't separate the water from the land. It's the system. And it's picking up where Sylvia was, is I'm a believer in the concept of Gaia, that the earth itself is a creature, and that it lives in hopefully a symbiotic relationship with life on the planet, certainly with most of the planet. But the human race is now becoming a threat to all of the above, a threat to the planet, a threat to all its life. And I think the earth is fighting back. I think we need to really think about what's going on right now. The earth, I think, has now recognized our presence and sees it as a threat. And I think the deal we've got to be able to cut a deal with this planet so that we're living in a symbiotic relationship with it. So understanding the whole system, but certainly a big part of that whole system, as Sylvia pointed out, the largest living space on the planet is the midwater zone, which is probably the least explored in the oceans. Yes, we're doing a really good job now on exploring the bottom of the ocean, but we really need to look at the whole enchilada. And this whole new program, the program that Woods Hole has with the Mesobot, we're looking and tracing and following creatures. That is so exciting. I think we're at a critical moment in the history of the human race, because we've got to save this, not only the planet. I'm not really worried about Earth being here in 1 billion years. I'm worried about us being here in a couple hundred years. And so we really need to understand this planet more than we've ever understood it before, and time is running out.
we need to make peace with the planet.
Absolutely.
Yeah.
And I'd like to pick up on a comment you made about an enormous part of that Earth atmosphere, land, sea system that we need to understand better in order to understand those the challenges that we're facing is the ocean. And doing a little bit of background research for this panel, I couldn't help but stumble on Dr. Don Walsh's name a few dozen times when it came to exploring the deep parts of the ocean. So I'd like to hear, Don, your thoughts on that first question before discussing some of those challenges that Dr. Ballard just mentioned about the ocean, what percentage of it's been explored, and why, what challenges there have been to exploring the ocean.
Well, I think one of the things that concerns me a bit is we've been pretty easy, pretty loose with saying that only 5%'s been explored, 10%, 15%. Last number I saw from NOAA, and maybe Kathy can correct me on this, was 85% unknown. Still, that's, call me a liar for 10%. That's a big unknown, big question mark. The thing that concerns me, and I think we in the ocean community have to be very careful on this, is we don't really define that term exploration with respect to how much is known and unknown. And we have a rough topographic idea of the shape and form of the world ocean seafloor. We don't have a lot of detail, but how do we define, in this context, exploration? I just hate to see us get caught out by being accused of kind of using a rubber ruler to make these kinds of statements. I've never seen anybody question that before, so I guess I'm a lone voice. But I think with such a critical thing, exploration of the whole world ocean, we need to be careful what we mean by how much has been explored, how much has not been explored. There is a program underway now with the International Hydrographic Office in Monaco to map the entire floor of the world ocean by, what is it, 2030? I don't have that in front of me.
2030.
But
Yeah.
2030, okay. And that's a very ambitious program. And when they say map, now we get into the question that Kathy kind of implied, and that is resolution. That's the big thing. What is the resolution? Now, moving off of that for a minute, I'm just leaving that as an open concern of mine. I've had the good fortune to be on 3 expeditions to the Challenger Deep. One that I did 6 decades ago, and then with Jim Cameron in March 2012, and then 2019, last year, with Victor Vescovo and his 7 Deeps expedition. And it's just amazing to see the arc of technology and, you know, what's doable, what's possible now. In fact, between Jim's expedition in 2012 and Victor in 2019, it's astounding. The submersible system that he has was able to make 4 dives at Challenger Deep in 8 days. And Victor piloted 2 of those. And then this year, in his Ring of Fire expedition, which is sort of ongoing now, they've had some technical problems, but I think they're going to resume early next year. They've done a lot more. In fact, Victor, I think, has made 8 or 10, piloted 8 or 10 dives to Challenger Deep. Think of that. I know how hard it was in my time. We had considered a second dive, but we just couldn't manage the logistics. And Jim, for a variety of factors, wasn't able to do more than 1 dive. So we're beginning to scratch around in these deepest reaches of the ocean. And it seemed to me, you know, Jim made his dive a half century after I made mine. And I take no pride in the fact that I have an alleged record and blah, 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 all that stuff, because I would have been really happy, elated, if somebody had been out there 2 weeks after we had been, Jacques Picard and I had been there and was doing it. It means we just left that small corner of the world ocean untouched. And yet, if we're to understand how our large part of how our planet works, we know a lot about where seafloor is being created in the spreading centers. We know very little, although it's getting better now, about where it all goes. The other end of this is like a giant conveyor belt. We got the source. We don't have much information on the disposition, where the stuff goes, and trying to understand some of these fundamental Earth processes. Now we're getting at it. And people say, well, look, only 2% of the world ocean floor is the deep trenches. And if you can build a submersible, manned or unmanned or observation system that can go to 6,000 meters, roughly 20,000 feet, then you can look at 98% of the seafloor. So as a bean counter, what a deal. I mean, for a capability, something less than, a little more than half the full depth of the ocean, world ocean, you can get 98% viewing area, if you will. But that begs the question of the deep trenches, that last 2%. And I know Sylvia's pointed this out for years, that that's like saying you can't go to the top of 2% of the mountain. I'm extrapolating your words from long ago, Sylvia. The general idea is, why would you forbid not full access to everywhere? Well, now we're doing it. We're doing a very efficient system. And I know Kathy is more recent on this than I am. It's last June, was it, or May?
Yeah, June.
Go there with Victor. And so you've seen the whole system. It's an amazing thing. Now,
but the point,
your heart is only about 2% of your body, too.
Yeah, there you go. Very well put. So the point here is the world now has a system that allows scientists to go to any part of the ocean floor, a complete system. And I think that's an important notion, system. You just can't have a submersible ab initio like we did with the Trieste Jim had with his sub. You have to have a complete system, the mothership, the landers, all the instrumentation, and a wonderful seafloor mapping system that they have on board that ship. which does hydrographic quality output, stuff that can go almost right on to the charts of the seafloor. And they did in the five deeps expedition last year, 2019, they did something like 250,000 square miles of seafloor, most of which had not been mapped before. So it's an amazing system. And I guess you guess from my comments, I'm pretty much a supporter and enthusiastic about it. At this point, I'll sign off because Callie, I'm sure that Kathy can give us an update and improve knowledge.
Actually, what I want to, Chris, what I would like to pick up on, sort of drawing a string through Sylvia and Bob and keying off of Don's worlds. It's great to talk about how much has been explored, and that is kind of an acreage or a yardage sort of discussion, if you want. But what I think about is the other word we've used here is how much do we know? And that's really where I key in, because to me, I'm on this point of living wisely and well on this planet. How do we do a better job of living wisely and well on this planet? That's not just about where have you been or where did you peak at or where did you make a measurement. That's about what you actually know, what depth of understanding of the processes and of the interactions between these systems. Sylvia's put her exactly right when she says it's an integrated system of systems that's physical, chemical, biological, and atmospheric, by the way, because the atmosphere interacts with the ocean and vice versa. And so when I think about what is the big challenges and the big opportunities in going forward with both ocean exploration and, more importantly, actionable, valuable ocean knowledge, I think of two things. Bob put his finger on one of it, the mesopelagic, this massive segment of the ocean that's full of life and a vital tranche of both the ocean food chain and of our life support system. But then my technical brain kicks in, because the other challenge I think oceanographers need to overcome is fundamentally a geographic and a technical challenge. It is too much the case today that each expedition, when it goes out, whether that's a single university lab or Caladan or NOAA, there's still much. I'm going to be deliberately a bit brash and unkind here. It is all still rather too much artisanal. It's a new instrument. It's a particular data system. It's a certain format. And so you get lots of little dots of insight, but they cannot be collected and aggregated. They don't become tiles in a unified mosaic. But metaphorically, we need to API the ocean. We need, or as with my NOAA hat on, oceanographers need to start acting more like the World Meteorological Organization, that there is some coherence and some unity and some standards about how we report and measure and record anything we have observed, so that the next group along can put the pieces together and not just look at my paper or Bob's or Sylvia's, but start to see the greater mosaic in area, in depth, and most importantly, in the living web that suffuses the entire world's ocean. How do we get to that point where our knowledge can become 1 + 1 is not 2, it's 1 + 1 is a half now. How do we get in the direction of 1 + 1 is 3?
If I could jump in, I think that we're right at the edge of the first time when it's possible to realize that vision. ESRI, the organization that does GIS mapping and integrating information, turning their attention in recent times to the ocean. What we're doing with Mission Blue, with our now network of 133 so-called hope spots, they're not fully protected, but engaging communities, scientists, individuals to use the ESRI format of story maps of a common framework that taps into the same kind of technology that NOAA uses, that NASA uses, that universities around the world use. I mean, whatever it takes, you're absolutely right, to be able to gather information with a format that is shareable, and consistent, and to be able to really look at change over time. That's
And
that's
and
the re-
and measurement standards. I mean, a
no,
key
absolutely.
factor in why we all enjoy a decently worthwhile weather forecast is
Right.
because all of the countries on the planet more than a century ago agreed whatever they wanted to study and measure, they agreed to consistently, regularly make a certain set of measurements according to certain standards with certain precisions, and then certain reporting formats. And it's actually a very thin layer of standards and data underneath all of the abundance of atmospheric research. But it is a powerful, it's like the connective tissue of your body. It's what makes the integration and synthesis possible. It's what makes it possible for us to represent and model the entire globe atmospherically and make forecasts that can actually help shape decisions that we face in our daily life. Let's get to that in the ocean, and in particular with respect to the living systems.
And coupled with that, I'm going to poke Bob Ballard just a little bit because
She loves to poke me. She's my wife's cousin, so she really likes to poke me.
It is a great sport, Bob.
Poke away.
and also to send you a big bouquet, because in the time of the pandemic that we're now experiencing and what we're doing right now, face to face, but we're not together, it's the virtual appearance that has come a very long way in the last 50 years. Used to be the telephone and party lines and all of that, but now we have the capacity to vicariously visit. Well, I have seen what you've seen, Kathy, because you brought back images and
Right.
your personal experience you shared with me and the world. I don't imagine, I mean, I've been up 11 kilometers in the sky, as deep as you and Bob are gone, and now a handful of others have been deep in the sea. In fact, gazillions of people have been 11 kilometers in the sky, but I haven't been far enough up in the sky to really grasp Earth as you have seen it, but you have shared your view. And I think that's transforming everything. The ability not only to send our instruments, to send the cameras, but to send our telepresence, to use Bob's language, but also to take real live individuals. It was not just a camera up in space, it was you, Kathy. And
Well, and Bob's done that at sea, not just sending pictures home, but taking us with him out to sea. And I think that's a huge, perched on your shoulder, Bob, feeling like kids or usins are with you. That enriches the experience for everyone who's taking part.
I'd love to talk about that a little bit more. I mean, I looked at the sailing log for some of the recent Nautilus trips, and I see brilliant scientists, incredible engineers, and then media people and graphics people, and people who specialize in content. And that can't be easy. What made you prioritize, the ability to share and communicate what you're doing?
A real simple story. When I was a little kid, I wrote a letter. I wrote a letter to Scripps saying, I want to be an oceanographer, and I'm dyslexic, so I'm sure I misspelled it. And they were kind enough to answer my letter. And not only did they answer my letter, they let me go on my first expedition in 1959 when I was 17 years old.
Wow.
And I fell in love with it. So think about the letter I wrote that normally ends up in a trash can. Someone answered it. So I come back from the Titanic in the first week, 16,000 Bob Ballard letters came to me. And I had a moral obligation. I could not say no. And that's why I created the Jason Project, to be able to take all these kids with me. And yes, I love the experience of being there physically, but I also, I had a big, long discussion with Jim Cameron just the other day. When I watched Avatar and I watched the guy leave his body and go into a Na'vi, he basically moved his spirit. And that's what I'm really into. I look at my hands as an amazing robot, but I separate my spirit from my physical body, and I want to beam people. I want to take their spirit, because I can take them by the tens to hundreds of millions, something we just can't do with a lot of physical bodies. And
Right.
that's why right now with our expedition, we take millions and millions of kids because they can literally beam them down, Scotty. And so I love it all. I love physically doing it, but I also know that my spirit is indestructible and can move at the speed of light. And particularly as I get a little older in age, I'm relying upon my spirit a lot more than I am my tongue.
But Bob, it's not either or.
It's both.
It has to be both.
Yeah.
If we
Yeah.
just had cameras up in the sky, it wouldn't be the same as having Kathy up
Yep.
in the sky.
And it's appalling how many kids in America can't swim. If you can't swim, you're terrorized about the ocean. We need to make sure that every child on the planet, but certainly in our own country, particularly people of color, 90-some% don't know how to swim. It's
No
hard
child,
to say when they're terrified.
no child left dry.
No trout left dry. I love that.
In the water, and everyone knows how to swim, but I also know I'm a land-breathing animal.
Yeah.
5% of the human race, 95% of the human race live on less than 5% of Earth. There's a reason.
We
Yeah.
we always underestimate the value of communicating, but if you think about all the challenges, Bob, that you mentioned at the beginning of this, the challenges that Sylvia is working on in her hope spots, to me, one of the biggest challenges to overcome is that these problems seem less accessible to people. Like, we're used to seeing something on land. We're used to seeing a deer or an animal that we've seen in with our own eyes. We can understand conservation challenges that are related to that deer, that animal that we understand on a personal level. But the ocean seems so far away. I mean, not opaque just to our senses, but to our imagination. And so what you've done with communicating, the ocean, I mean, and for lack of better words, making oceanography cool, making it accessible to so many people is so important.
I think one of the big breakthroughs happening right about now is to recognize that there are communities of other beings on the planet that we can relate to. Not that should be all important, but it is, because we are a dominant force in changing the planet right now. But it's come over the past few decades, understanding, for example, the societies of whales and the communication that they have, the family structure, and it comes from really getting to know individuals and their relationship over decades, to know not only how long they live, but what kind of relationship do they have with their families, whether they're the orcas up in Puget Sound or the sperm whales that have been tracked down in Dominica over a period of now 20 years. And to know their name, I mean, it's really a human thing, but to give them names. Jane Goodall got a lot of flack from the scientific community because she gave chimpanzees names. You can't do that. That's anthropomorphizing the animals and personalizing them, and you have to be detached. Well, that's nonsense, she said, and I say too. Getting to know how these creatures live, and then to be a tuna fish, if you could just imagine what it takes to get from one tiny little speck into a full-grown 1,000-pound giant. Again, it's a miracle that any of them survive. And then until we came along, their biggest threat, probably orcas and sometimes big sharks would eat a tuna. But when they're grown up, when they're small, they get eaten by everybody. Just tuna lunch for. But the thing is that if we can get to know them, to empathize with who they are, not just what they are, and there needs to be I think, an ethical transformation about the way we treat other forms of life on the planet. On the land, we've come a long way. We have policies protecting birds. yes, we still have a long way to go to protect and respect other forms of life on the land. But in the ocean, people say fish and they think, delicious. Lemon slices, butter, fried, baked, rather than thinking of life in the ocean as something to be treated with dignity and respect, and not just to think of them first and foremost as commodities. We used to think of whales first and foremost as commodities. We've sort of evolved with a different relationship, and those of us who are here gathered right now, we're witnesses to the transformation in the ethics of how we treat our fellow mammals in the sea.
Dr. Earle, I'd love to dive deeper into that, because the part of it was motivated by what we were talking about before, which is how distant many people in the world feel from the ocean, just by pure proximity, or by the fact that people don't interact with the ocean and they're scared of it. They can't swim, whatever it is. The ocean's hard to get to, and there's that distance. And that's the kind of thing that the scientific communication that Dr. Ballard's been working on is so important for. But another part of the two challenges that you just mentioned, which is, with the marine mammals and how, we used to think of whales as a commodity, we still think of tuna as a commodity, brings up another issue that I'd like to mention, which is that the ocean in a lot of ways can be considered almost the ultimate tragedy of the commons, and that anything that any of us do to the ocean affects the entire ocean. Tuna, for example, are highly migratory. If we catch all the tuna in our waters, they don't get into someone else's waters, which means solving a lot of ocean problems requires levels of international cooperation, which are enormous and often challenging. And I'd like to ask Dr. Walsh briefly about that, because as I understand, he was on the Law of the Sea Advisory Committee for the Department of State. And that is, I think, from an international cooperation perspective, a triumph in what you guys were able to accomplish. Could you comment a little bit, Dr. Walsh, on the international nature of some of these issues and some of the challenges that pose?
Sure. First of all, I think the Law of the Sea Treaty was a remarkable enterprise. When you could get all of the nations of the world to agree on a somewhat uniform legal framework for the world ocean. And
do you think you could describe the Law of the Sea very briefly for our viewers who might not be as familiar with it?
Oh, gee.
Sorry to put you on the spot like that. The 30-second version.
Having sat through some sessions in New York at the UN, I've seen geological formations that move faster than that lot. There were three Law of the Sea conferences. The first one was 1928, and really didn't do much, but it was the beginning. And then in the 1960s, there was a second one which defined the outer continental shelf, which was very important because it gave to the coastal states certain rights to the adjacent coastal waters out to about 200 miles. And then the third conference more or less institutionalized all of that and added many other things. I was on the Committee 3, which is Freedom of Scientific Research, because once you have given a coastal state rights, but not sovereignty, rights to a 200-mile wide swath off their shoreline, then that implies a certain agreement that they had regulatory functions. So if you come in there with a scientific research ship and start working there, then that's considered to be working in their area. If you're not doing anything, and that's called innocent passage, then that's fine. Every nation has the right to send their ships through the 200-mile exclusive economic zone because you are innocent passage. You can't stop and do things, fire off missiles or do science and so on. So this all of a sudden gave all the coastal states in the world the ability to put a hand into the pot with respect to scientific research. The nations were not supposed to deny access for scientific research unless there was a very valid reason, but they also were given the right to participate in such an expedition. Well, you can imagine from the country of Togo on the coast of Africa, of West Africa. A little difficult to round up enough oceanographers to go to sea on a script ship or Woods Hole ship, but that's their right. And they also have, that government has the right to the scientific data that might flow from work carried on in their waters. But I think what's really amazing, the fundamental thing, is that how you could get 165 nations, I think it was the time that the treaty was finally signed, not ratified, but signed by the signatory states around 1991, something like that. And still could agree, because so many of them, and especially certain nations, think they have their hands on the levers and their feet on the pedals. And it's really hard to get everybody to agree to things. And yet it happened. And when it started out, by the way, the third UN Law of the Sea Conference, there were 65 nations. I mean, you could almost invite them to dinner and hammer it out over a pastrami sandwich. But by the time you had 165 nations, I think the count's up to 180 now, something like that. And yet it worked. I think it's just amazing that you could get the international community to agree on anything. So it's a good paradigm for a lot of other activities we're trying to do internationally, whether it's, climate change accords, things of that sort. And why was I involved? I was a naval officer. I wasn't a lawyer. I didn't have any background in maritime law or international law. But my feeling by imposing myself on these lawyers was simply that it's too important to leave to them alone, because I, as an ocean person, and everybody else on our panel here, have to live with the consequences of what these people did in New York, the Law of the Sea Conference. So I got involved that way, just to kind of make sure I understand what they were doing, and perhaps give the blue flavor to the discussions. This could be a 3-unit course in university, the history and execution of the Law of the Sea. So,
do you mind talking a little bit about the challenges associated with the IOC and data standards? IODC, excuse me. Thank you very much, Dr. Earle.
I would rather push that over to Kathy, because she was responsible for a lot of that stuff during her as chief scientist of NOAA and later as administrator of NOAA. So yeah, Kathy's more up to date than I am. And of course, Sylvia was asked the question and I jumped on top of it. So I'll stand back for a moment, please.
Well, let me take a stab at it without droning on too long. There have been efforts in the past to try to forge a single repository, a unified repository for oceanographic data. And the one that comes to mind is the IODC, the International Oceanographic Data Center, back when, Don can tell me, I think in the 60s sometime. But the problem was the IODC was basically a big bucket that welcomed anyone to pour whatever they had into it. And that's nice. But if you think in comparison to, say, the World Meteorological Organization, what you're trying to do is bring together data, measurements, observations in a way that lets them really be additive and really scale up to a deeper understanding, deeper insight, and prognostic and forecasting capabilities. And if you want to move in that direction, you not only need a bucket, but you need very clear agreements that are peer enforced about what is the essential set of measurements everyone will commit to make. You can make whatever other ones beyond that you wish, but we all agree we'll do these X number of measurements. And then you need, even more importantly, you need agreement about standards and calibration. So I need to be able to know that when Bob measured the concentration of something in an aliquot of seawater, I know that's an accurate, precise measurement, and it compares to mine in a certain way. I can count on that. I've got quantitative rigor to it. That's what has not happened yet in the ocean world. To the best of my knowledge, and I welcome my colleagues to teach me and correct me here, I think but the world of oceanography is still exploding in a lot of dimensions. So we're moving into the whole era of omics, really getting down to the genetic level of things. Now would be the time to get clarity among not just every nation, but every oceanographic entity that goes out to sea to do research. What are our standards and calibration and formats going to be for recording omics, so that every water sample, every cast into the deep sea can be synthesized and brought together. So our efforts and our successes thus far on standards and calibration and data uniformity lag far behind what the challenges of our times and the challenges of the future really require. I come back again, Jeff Bezos made a great speech a couple of years ago to his whole workforce about the API imperative, the absolute imperative for everybody anywhere doing anything in Amazon to adhere to the API standard so my stuff could connect to everyone else's stuff. And flat out said, if you don't or won't uphold this standard, you're going to leave this organization. That's the sort of maniacal scale of rigor that we kind of need to get to. It's hard. It's terribly hard among nations.
Yeah,
It's even harder among independent research laboratories that are pioneering new instruments and working in a very artisanal way. But I think we have to get there if we're going to. What I want to see us have in the ocean, again, in particular with respect to the living ocean, is the kind of foresight about future conditions that we have now with the atmosphere of our planet. I can tell you what the weather's going to be like here in my hometown 2, 3, 5 days from now with confidence that you can bank on. How do we get to that level of foresight and forecasting, predictability on key attributes of the ocean? That's what this could enable.
That is a good starting point for the physical and to some extent the chemical nature of the ocean, but the biological nature is another whole matter, and it's particularly complicated because of the commercial interest in life in the sea. The fisheries, not about the fish, it's about the fisheries. How many can we kill? How many can we catch? How many can we sell? The commodification of life in the sea. And the estimates, and it really are estimates of how many tuna are there. We have a better idea of how many whales because we can kind of see them at the surface. But how many tunas, how many shrimp, how many of this, how many of that? It's important because we calculate as if we really know how many tons, not individuals, how many tons of whatever animals we're trying to take are allowable, with a goal of having some possibility of a sustainable catch, which is probably not very realistic, but that is now facing a new set of tools with the ability to sample the genetic material that's in the water. At least you can get a qualitative idea of who has been in this body of water by sampling the genetic material that is there, something that we couldn't imagine, I think, even 10 years ago.
Yep.
So we're getting tools that give us better insight to cope with the questions. So we had a question on the table about the law of the sea, and the sea doesn't care. It's law that governs humans in their relationship to the sea that we really need to look at. But given that we have nations that miraculously have come together, at least with respect to assigning jurisdiction over the ocean within for coastal nations, but there's half the world, roughly, high seas, that is truly the global commons. It remains the global commons. And yet, I mean, right now, 2020, 2021, right now, this is a pivotal time when nations are struggling, through the United Nations, struggling with assigning places in the sea that would be protected, where we would not kill the fish, where sea traffic would be regulated in some fashion, the corridors over which the big ships travel, and to try to understand our impact on the nature of the ocean, knowing the connection between climate change and the ocean. I mean, what a breakthrough. That's why NOAA was basically formed in the first place back in 1970, to bring the ocean community together, put it this way, the ocean community together with the atmospheric community. It's one system, but what has been missing until fairly recently is the principal role that the ocean has in governing climate. It isn't top down, it's bottom up. It's the ocean really makes possible the climate that we have. And it isn't just a physical or chemical thing, it's a biological thing. And back to the biogeochemistry and the importance of life in the ocean for more than pounds of meat or barrels of oil. It's life in the ocean that captures the carbon. It's life in the ocean that generates the oxygen. It's life in the ocean that shapes the chemistry. And we have been mindful of it to some extent, but when it comes to making policies about protecting our life support system, maintaining Earth as a habitable planet in a universe, as far as we know, no place like home, no place that has an ocean filled with life, at least our kind of life. We are children of this planet. Our deepest roots are here. And much as we might wish to transport a colony or even civilization elsewhere, if we don't make peace with Earth and take care of it, we won't achieve those other dreams far out into the future. But the opportunity that now exists to maintain the integrity of the ocean through protective policies where you don't kill the fish, where you are mindful of what you're putting into the ocean, what you're taking out of the ocean, where you respect the most important thing that we take from the ocean is our existence. And to realize that we have to stabilize our relationship with the planet as a whole, land and sea, forests, freshwater, and ocean. But we're further down a level or have a better understanding of our relationship and the need to take care of the land, trees, birds, fresh water. Not doing a great job, but at least we understand we have to. The ocean seems so big and so beyond what we could get our arms around that we've neglected it. We put anything we want to in the ocean. We take out of the ocean without thinking about the consequences. But we're starting to right now, back to this being the pivotal time in history, the first time that we have the capacity to understand, and maybe the last time you have a chance to do something about it.
Dr. Earle, that's exactly where I was hoping we could take this conversation. We've spent a lot of time talking about the challenges facing the ocean and the challenges facing those responsible for studying and exploring the ocean, from international cooperation to lack of data and standardization, scientific communication, the economic problems associated with the commodification of sea life. To bring this panel to a I don't want to say more positive note, but I'd like to hear what we can do about it. And in particular, as explorers and scientists, what we can do about it. And so I always thought it was very interesting. Dr. Ballard, your vessel, the Nautilus, the vessel that you've done so much work with, you call the exploration vessel Nautilus, not the research vessel Nautilus, as many other folks do. And so I guess I'd like to hear your thoughts on, as scientists and as you would describe explorers, what can we do about all of these challenges that Dr. Earle just mentioned? Like, what is our role in order to do something about it?
Well, I mean, I may come out of left field on this one, so get ready. We do get, all of us on this panel are commonly asked some pretty tough questions. And I did learn, having served on all sorts of panels and commissions and you name it, that if you give the politicians a choice, they'll cherry pick it. They'll pick one of the easiest things on your list and then feel like they did their job. So when I'm asked this, they say, what's the single most important thing the human race can do to save itself and the planet? I have only one answer. the empowerment of women. And this always catches me. I'm a man saying I'm doing this selfishly. The planet, if you calculate the carrying capacity of the planet to feed humans, and if you start with them all being vegetarians, which is we're a long ways from that, and America's the worst example. But if you make the assumption that every human being on this planet is a vegetarian, we run out of food in 2050 to feed it. The Earth cannot feed a population that hits 10.5 billion. It just can't do it. Getting back to the calculation that 95% of all humans live on 5% of the Earth. And we build our houses on our farms. So if you look at the loss of farmland, it's staggering loss of farmland just to house people. And so then you get back to the whole issue and the controversy of going away from a hunter-gatherer society in the ocean, which is what we are. Can we farm it in a way that lets the wildlife return? If we as long as we don't drive something to extinction, if we give it a chance, it'll come back. You do hit certain levels. We almost done it with certain species of whales where you drop below 25, you lose them. You have an extinction. But we're having the Earth has had multiple mass extinctions in life. But this is the first mass extinction created by another creature, and that's us. So it's all about the empowerment of women. And the more you empower women, you get population under control. And that's the only hope we have. So that's
more minds thinking about the solution as well, right? I mean, if we have the entire population working on solving the problem, we're a heck of a lot more likely to come up with good solutions.
And a third point that I would argue from my experience, both of those are true. You get population under control, you get more minds working creatively under the problem. The other point is you will get a shift in the ethos, because if the predominant male dynamic in decision making is competitive. It's get mine, it's maximize, it's accelerate, it's go fast. When you add a large proportion of women to that mix, other value sets, other cares come into play. And to summarize them in a hyper concise way, it boils down to greater care for the other. I mean, just this week, I was talking with an senior executive at an organization that had two women vying for a large job. And he decided to split the portfolio between the two of them. But as he was interviewing them ahead of that step, at the end of their individual interview, competing for the big portfolio job, each of them talked about the other woman, how competent and capable she was, how ready for the opportunity she was, how deserving of a chance, and how the speaker wouldn't want to harm the other one so badly. This executive commented to me that never would he ever get that kind of concern expressed by a man in that competitive posture. So it is, Sylvia and Bob, I think both have talked about, an ethics transformation. It's a value set enrichment that needs to come to many of these decisions, and bringing women into the decision-making inner circle, into the moments that matter, not just into the scientific enterprise and contributing the data, but at the table where the debates and discussions and decisions are happening. You've got to have a richer set of values in play, or this will not turn around.
We call it Mother Earth and not Man Earth for obvious reasons.
Yeah.
Well, it was
as every ancient culture has done, by the way.
It was Lynn Margulis, who was a partner colleague of James Lovelock. You mentioned the Gaia theory or idea, the concept, Bob, early in the conversation here. But Lynn was perceptive in saying that life on Earth has progressed over the gazillions of years that life has existed, not so much by the Darwinian competitiveness, but far more importantly, through collaboration, cooperation, social structure,
Symbiosis.
symbiosis, absolutely, right down to the cellular level,
Right.
which goes right back down to viruses and microbes, and how everything does connect, and far more progress has been made long before there were humans on the planet, and even now, and even among us, through cooperation rather than, fighting all the time. It comes with sharing knowledge, advancing. I mean, how did we get to where we are as civilization? People learn things, they pass it along, learn things, pass it along. So the kids of today, 10-year-olds know what Earth looks like from afar. Kids of today know what Einstein, as smart as he was, could not know because the technology had not reached that level, the communication of knowledge had not reached that level that kids of today now take for granted. And that's cause for hope, I think, that we have the knowledge. The question is, do we have the will? We are infected with this terrible disease called complacency. And it's holding us back from getting to this better place, that if we've got the evidence. We look at climate change. The evidence is right there. We know what to do. We can see, based on knowledge that has been gathered over the decades, looking at the trends. We're not making this stuff up. Do we have the will to take exploration of the ocean? The technology existed in 1960 to go to the deepest part of the ocean. It was 50 years. It wasn't a technological breakthrough. It was a mindset breakthrough. Somebody wanted to do it. And yes, there were some technological advances. And between 2012 and 2019, there were technological advances. But the biggest advance was somebody said, I'm going to do it. And using the technology that existed to make it happen. We have the technology. We have the knowledge. We must come to grips with the fact that the Earth is changing in ways not favorable to us because of us. But because of us, we can go from this to recovery, to finding that place that everybody says we should get to, which is sustainability. But it can't happen if we have beyond our carrying capacity. Earth is only so big. It never gets bigger. It's just this big. We've got to make peace with what we've got. We can do this. Can we do it? Will we do it is the real question.
So I once asked my old advisor, Dr. Walter Monk, what the biggest scientific challenge facing oceanographers today was. It was actually just a couple months before he passed last year. And I was expecting him to say something, computational, like modeling the ocean, and something about scales of large physical oceanographic phenomenon. But what he said was one word: cooperation. He said we needed to work together better. And that's been the theme that is sort of everyone has been hitting on throughout this entire event. And it's very interesting to me. That being said, we're starting to run out of time. So what I'd like to do is ask each of you for your answer to two questions in just a minute or two. The first, which is something that I myself am very interested in, is what do you think the future of ocean exploration holds? How do you think it will be different than the past? And you can take that in any number of directions. And related, do you have any advice for aspiring ocean explorers, people who want to make their mark, have an impact on all of the challenges we've addressed today? Do you have any advice for them? And so we can go in any particular order. I'll go counterclockwise on my screen. Dr. Walsh, you first. What do you think the future of ocean exploration holds? And do you have any advice for young ocean explorers and scientists who are entering that world?
Well, I think more of us have spoken to large numbers of children than we could possibly count, because all of us are investing on our future. It's as self-serving as hell to get out and talk to the young people, because to some degree, if you can mix the metaphor, they are a tabula rasa, a blank slate, and you write on that. And I say, how many of you would like to really leave your mark on our world? Every hand goes up. And I said, well, come on in, the water's fine. Because on land, yes, there's a lot to be discovered and seen. But every time you dip your toe in the water, as we all know, you're discovering things. It's just amazing. For example, this Hadel work that, the trenches work, biological work, every time you go down there, they're finding all kinds of things never seen before. And I said, look, if you want to see things, as the first human on this planet for the first time, and even give it a nice Latin name after your parents, and go in the ocean. Everything is new. The world of discovery is wide open, and you can be part of it. And by the way, it's fun because when we have conferences, we have them in neat places. And so that's my take. Now, the rest of my colleagues, with Sylvia and Kathy and certainly Bob, have worked a lot more than I have in working with young people in education. So much, it's so important that we turn around and put a hand out and help them come up, because they are our future.
Got it. Dr. Earle, your thoughts on the future of ocean exploration, and any advice or message for young ocean explorers?
Well, the kids of today have good reason to be have a sense of despair. You think of all the problems there are, but I say, be glad you are born now. This is the best time ever. What we now know that was not knowable when I was a kid. Kids of today have a head start, and 50 years from now, it'll be the same. We keep learning, and advancing as we go. But the greatest era of exploration is just beginning. We're just beginning to ask to know the magnitude of what we don't know, and what to look for, and where and how to get from where we are to a better place. Getting the physical and biological and the chemical dimensions of the ocean is still a major challenge, but we know enough to know that the ocean is in trouble. It's changed because of us. And those changes mean that we're in trouble. But we are so lucky that we can see it, we can grasp it, we know what to do. It'd be great if we knew more, and that's part of what the next generation will do. Dive in, go find out. But meanwhile, respect what we've got, protect what we can of the systems that are still in great shape. Find those coral reefs that are still in good condition and protect them. And in the deep sea, there's much talk now about mining the deep sea. I say hit the pause button. Just don't do it until at least we understand the trade-offs. We don't know. We don't know the magnitude of the changes that we may set in motion by now turning our attention to mining the deep sea. And we just can't justify the damage against the plus side of the ledger at this point in time. And so the precautionary principle with respect to the next phase of exploration, let's identify those places that we can embrace with the highest level of care, not just the bottom, not just the top, but whole big chunks of the ocean, large areas. How about the high seas? How about if we give half the world a break and say, this is our insurance policy. We need to dive in and learn about the deep scattering layer, about this layer of life, this carbon-rich layer, this place that has such an impact on the biogeochemistry, probably has a major carbon role in terms of influencing climate. We just need to find out. We're not going to have as much luck telling nations that already have their vested interests in the exclusive economic zones. But if the next phase of exploration could be directed to justifying protection, full protection for half of the world, the high seas that everybody uses every time you breathe, that everybody uses every time water falls out of the sky. Everybody uses all of nature, but we can protect through proactive knowledge and rationale and get the kids engaged because it's their future that's on the line.
Got it. Thank you very much, Dr. Earle. Dr. Sullivan, the future of ocean exploration and any advice for future explorers?
Yeah, I'm a little more like in Don's vein of things. I think I think the future of ocean exploration is one of invention and inventiveness. I think there's a whole new generation of equipment, of devices, of gadgets to help us better monitor, measure, learn about, study, keep the pulse on the ocean, the bio and the geo, I mean, all of it. And so if you want to jump in a field where you have wide field, wide latitude to be inventive, to discover things no human being has ever seen or encountered or understood before, things as dramatic, as spectacular as finding another planet in our solar system, I mean, of that magnitude, there are those discoveries to be made in the ocean, and those kinds of inventions to be brought to bear on taking better care of this ocean that makes our planet what it is, that makes your home Earth the viable, livable place that it is. So you can be the inventor, as you can be as inventive as Thomas Edison. You can be as great a discoverer as anyone you ever read about in your textbooks in the great age of exploration. And if you want to know why you ought to want to do any of those things, is because your inventions and your discoveries can come along at a point in time where you help change the course of the planet and change the course of humankind's future and your own future. So fun, creativity, the beauty of the ocean realm, and full reign for your inventiveness, your creativity, the excitement of discovery, and the absolute confidence that the knowledge and inventions that you add to humankind's store will add up to the betterment of all human life on this planet.
Got it. Dr. Ballard, the same question, the future of ocean exploration, what does it look like, and what advice do you have for the people who will be entering that world?
Well, your question reminds me of Charles Dickens' Tale of Two Cities. These are the best of times, the worst of times, the age of foolishness and the age of brilliance. I think we have a choice, and it's a choice to be optimistic or pessimistic. And I will always pick optimism. I also love a particular kind of human, and it's a human in middle school. I love going to middle schools more than any other group of kids on the planet because I know that they are innocent and pure at that moment, and they are born scientists. They just want to know. And I think what I like to tell them is I say, kids, think about it. Your generation of middle school children will explore more of Earth than all previous generations combined. You are at the cusp of exploration at the most critical time in human history and in Earth's history. So follow your passion and get on with it.
Thank you very much. So with that, we are running out of time. Thank you so much for participating, everybody. Today, we challenged the very definition of the term exploration. We talked about the challenges associated with ocean exploration, everything from the sparsity of data to lack of standards, international cooperation, commodification of sea life and the challenges facing the ecosystems. The fact that the Earth is not just the Earth's ocean is not just a sea floor, but it has chemistry, it has biology, and we need to understand everything together. And the term ocean exploration needs to include all of that. We talked about the importance of scientific communication and communicating our discoveries to the rest of the world to help make the ocean just a little bit less opaque. We talked about how to solve all those problems too, which largely centered around empowering women, improving education, investing in young people, helping people become passionate about solving all of these problems, and above all, in order to give us the information we need in order to solve all these problems, keep exploring. So I think with that, we're out of time. Thank you so much, everybody. Dr. Sullivan, Dr. Earle, Dr. Walsh, Dr. Ballard. It's been an absolute pleasure and an honor for me to host this panel. Thank you very much, everybody. Have a good afternoon.
Thank you.
Thank you, Chris.
Thank you.